Good afternoon, everyone. Thank you for joining the webinar today. Today I'll be speaking about Sharcnet Cloud. My name is Mohammed Al-Sakhawi and I'm responsible for Sharcnet Clouds. The agenda we have for this webinar will be: first, what is cloud computing and how is it different from traditional computing? How to request access to the Sharcnet Cloud. After you get access, how do you create virtual machines and use them? We will end by mentioning some notes about the Sharcnet Cloud and use cases, and we'll be open to questions after that. So first, let's start by explaining what is cloud computing. So in traditional computing, whenever a certain user needs computing resources, the user will go and buy a physical server. The first server will have CPU, memory, disks attached to it. And every new user means a new server is created for him or is purchased for that. The problems with this approach is basically that the management of physical servers is a hard task. Whenever a problem happens with the physical server, it's very hard to detect, especially if it's a hardware issue. You have to keep track of everything that gets used by the physical server, such as hard drives, CPUs, and memory. So management of physical servers is a hard task. Plus, if you want ever to expand by adding more physical servers, now you need more space, power, and cooling. And this is not usually an easy task, especially if you're confined by space or your power consumption cannot exceed a certain limit. Third portion is resource utilization. And basically, if a user buys a server, how can you make sure that you're utilizing this server to 100%? So if we're looking at this particular image, a user would have a single server. It's an easy to manage task. But if you have many users, now you have lots of servers to manage, and they could not. There's no guarantee that they will be 100% utilized all the time. So the resources might actually be wasted. So the first solution that came out to place was computing virtualization. Virtualization is about moving from a physical server per user perspective to a virtual server. A virtual server, or commonly referred to as a virtual machine, is a virtual implementation of a physical server. So you can have virtual devices such as virtual NIC cards, virtual CPUs, memory as well attached, virtual disks, and you can have multiple VMs living on the same server. Now you have reduced the space and power needed because you could host multiple VMs on the same physical server. And also you could increase your utilization because if you have many VMs running on the same physical server, you could at least guarantee that one of them would be at a certain point of time using more resources than the rest, or at least the overall user utilization is going to be better than a single physical server per user. VM would look like that. So you would have, let's say, 6 VMs running on a single physical server. So it's from economic perspective, it's better resource utilization to have this sort of sharing a physical server by the VMs. But is this a sufficient solution? There is actually still problems associated with that because whether you're buying physical or virtual servers, you still have a human factor associated with it. Humans still have to provision the physical server. They have to create the virtual machines on top of the physical servers. They have to configure networks and so on. And still, you still have users that have specific security and isolation requirements. You could have a user that requests not to share the same network as other users. So basically that the traffic going to his application cannot be listened to from other users as well. Or you could actually request firewalling between the VMs living in the same host. So because multiple users can live in the same physical server, they might request firewalling in between them as well. So cloud computing came as a business solution for that. It's not 100% technical solution. It's more of a business approach to make those problems that I just mentioned go away. So it allows virtualization of infrastructure with first a self-service model. So you could, to a large extent, move away from a human factor. So in a cloud computing, users can create their own VMs using a web portal. So any of you as users can just go into a web portal, create a virtual machine, and connect to it without any involvement from the cloud administrator to do that. Also, isolated virtual networks. So a big portion of the cloud allows you to isolate networks between users, such that users cannot listen to each other traffic or cannot reach each other networks at all. And this solves a big issue for users with big requirements in isolation. Also, virtual firewalling between VMs and each other and public networks. So you could easily select that your VM cannot be reached except from a specific IP or specific IP range, and what kind of traffic can come through the VM or be accepted to leave the VM. Cloud computing introduced a security group concept, which is, we will explain it later, but it's basically the way that firewalling is implemented in the cloud. Security group defines what traffic can flow ingress and egress. Ingress is basically traffic coming inbound to the VM. Egress is the outbound traffic, so traffic originating from the VM and going somewhere else, and also allows from where this traffic is accepted or denied. Openstack was a project created in 2012. It was initially created by NASA, and then it was taken over by the community. It's a cloud-enabling framework, so it implements the ideas that I just mentioned in the previous slides. It's an open source project, community-driven. Usually features are implemented based on community requests or the industry even requests. There are many industry and research academic adopters for it right now. And it has a self-service web portal. So this is basically explaining more about the self-service model portion of it, that you could log into a dashboard in Openstack and request a VM to be created, and it will be created for you without any involvement from human personnel at Sharcnet. The dashboard that exists for Openstack is called Horizon. For Sharcnet Cloud, we have implemented OpenStack Cloud with multiple compute nodes and a dashboard for users to access it. This is the URL for it. It's https://cloud.sharcnet.ca/dashboard, and it's by request only cloud. So users will have to request access to the cloud in order to reach it. The default allocation that is given to a user is 4 cores, 8 gigabytes of memory, 50 gigabytes of persistent storage, and I'll come back to this particular idea about persistent storage in a minute, and 1 floating IP. I'll also explain more about each concept of these later on in the presentation. So how do you request access to Sharcnet Cloud? You will have to open a ticket, either using help at Sharcnet.ca or using the portal. And what needs to be included in this ticket? You would need to include the use case for the cloud. So what is the usage for the cloud? What's needed for, basically. And your PC/laptop public IP. The easiest way to find this out is to Google what is my public IP or what is my IP. Google usually will show you the IP for that. And how long is this account and the VMs needed for? We usually try to make the best out of the users available. So if certain VM or certain access needed only for a few months, then we could use it after for other users or other purposes, basically. So how does it look like when you reach like a Sharcnet Cloud? So you've been granted access, now you want to access the cloud. You go to https://cloud.sharcnet.ca/dashboard, and you'll be greeted with this username/login interface. You will have to use your Compute Canada's username and password. So whatever you use to access Gram is basically what you will need in here. And when you just put your username and password in, you will be seeing this particular page. In this particular one, what you see up here is called demo. So this is a demo project I created specifically for this webinar. It tells you here that you have used 0 of 10 instances, 0 of 10 virtual CPUs, 0 of 50 gigabytes of memory, 0 of 3 floating IPs, security groups, volumes, and volume storage. As I mentioned, the default allocation is 4 cores, 8 gigabytes of memory. This is different from the default allocation. And this is also to show an idea that the default allocation can be changed. So it depends on the request, it depends on the use case for it. We could have different quotas assigned to users. So in this particular image that you see in here, there is no instance have been running. no CPUs, no RAM, and no floating IPs. I'll explain every single concept of them in the next slides. So what does it mean by instances? Instances are the VMs that consume CPU or memory resources. So the Openstack way of mentioning VMs is to mention them as instances. They can either be ephemeral or persistent. Ephemeral is a kind of VM where its local disk lives on a compute server. So the cloud itself is formed of servers and storage backend. So if you choose to have an ephemeral VM, your storage for the VM will live on a server, a compute host. But if you choose to have a persistent VM, your storage for the VM will be stored on a back-end storage server. Obviously, the storage server is more reliable. We maintain multiple copies of it. Having it on the compute host instead of basically as ephemeral instead of persistent, the VM might be faster because it's accessing local disk. You could get more space because we're still confined by a certain limit for the persistent storage. So that's basically the major differences. If it's something that needs the data on it is very important and you need always to really have multiple copies, persistent will be the right choice for you for your VMs. In order to specify the CPU or memory for instances, flavors are used. So flavors is also another concept introduced in the cloud. Flavors are a predefined CPU, memory, and disk allocations. So flavors are defined by the cloud administrator and assigned to users. So in this case, myself, I'll be assigning flavors, or someone else within Sharcnet will assign flavors to the users. It will specify the number of cores, the size of memory attached to your instance, and the disk. So you could normally, when you start a VM, you could specify I want this flavor, and automatically you will be given this number of CPUs, this amount of memory, and this disk only for ephemeral VMs. Because as we just mentioned in the ephemeral versus persistent, ephemeral lives in the compute host, so the allocation for it happens within the flavor. If you're using persistent VMs, there is another way I'll explain just in a second. So volumes, those are the persistent storage on the storage backend. We maintain 3 replicas of them all time. So whenever you create a persistent volume in the cloud, there is 3 copies of your data within Sharcnet at all times. It's more reliable than ephemeral storage. So normally, the chances of ephemeral storage going bad is much higher than chances of persistent storage going bad. Because ephemeral storage is normally a single disk. If it goes bad, then the data might be lost. It has limited capacity, and that's usually the disadvantage of persistent storage. Is there is always quotas, strict quotas on it, because you have a very limited amount of persistent storage, and it could be slower because persistent storage is shared amongst all the users, and it is a storage backend server instead of a local to the machine itself. There is latency involved in that as well. The third concept I would like to explain is floating IPs. So I mentioned earlier that the default is giving 1 floating IP per user. A floating IP is a public IP that you could use to reach your own VM or instance. Normally, when you get to create a VM in the cloud, you get assigned what's called private IPs. Private IPs are not visible from the outside. You cannot reach your instance using the private IP. It's only used within the cloud itself. Public IPs are assigned manually to the VMs by the user. So whenever a user is given 1 floating IP, he or she can assign it to any VM that he wants after it gets its own private IP. This is how you reach your VMs. So whenever you create a VM in the cloud, the only way to reach it is using floating IP. The IPs will start with 192.168.164.xx at the end, so this will be changeable depending on the IP you will be given or allocated. And floating IPs are assigned to the VMs after they are created, so you cannot assign floating IPs to VMs before you create them. You cannot do this beforehand, basically. As Other concept is security groups. Security groups are the virtual firewall rules. They are applied to instances and define what traffic can flow in or out of instances. So you could always firewall the VM such that at the cloud level, I'm not saying talking only about within the VM itself, because those of you who are familiar with Linux, you could use IP tables or any kind of firewall within Linux to specify inbound and outbound traffic. But this firewall is implemented at the cloud level itself. It defines what traffic can flow in into your VM or outside of it. Even if you allow or disallow this traffic, even if you allow this traffic within the VM, the traffic still can be blocked at the security group level. You can also define what IPs you can communicate with. So if you have a certain requirement that your VM will only communicate, let's say, with specific IP, you can always specify this as security groups, and you can make sure that this IP will be the target for your traffic, basically. Users can create multiple security groups for instances, so you can have many VMs in the cloud, and each of them has its own different security group, such that you implement different firewall rules basically for your instances. The default security group is created when a project is created. So whenever a user requests access the Sharcnet cloud, he automatically gets created a default security group, which have very basic firewall rules. It allows everything outbound and blocks everything inbound. So mostly the most secure sort of rules is to block anything inbound until you actually choose to unblock that. So that's basically what gets created. The last concept I would like to explain is key pairs. If you're familiar with Linux, you could authenticate to Linux using multiple ways. One of them is using key pairs or public and private keys. If you're using Linux VMs in the cloud, you need to generate a key pair for that. And the key pairs will have two components. The first component will be a public portion, so this is injected automatically by the cloud to be inside your VM. And the private portion which exists in the user side in this case. So you will have the private portion of the key pair, and you will use it to log into your VM in the cloud. So now going back to the main interface that I looked at, so we can now understand many of the concepts we see in here as the instances, the virtual CPUs, the RAM, the floating IPs. As I mentioned, by default, you will get created one security group in the cloud. So that's why you see here one is used. So the default is for every user who gets an allocation in the cloud, a certain security group will be allocated. The volumes here, so those are the persistent storage that I spoke about earlier. And here the volume storage. It says here that the volumes are 0 out of 10. So you could create as much as 10 volumes for persistent storage, but they all should be within the 400 gigabytes that you're allocated. So if you create, let's say, 10 volumes, each of 40, you will be within the range. But if you create 10 out of with 50 gigabytes each, then you'll be outside this range. This is the first tab as you will see in the cloud. So whenever you log in, the next tab is looking at the instances tab that you see in here. If you click on the instance, those are the VMs that were created. But as you can see here, there's nothing has been created. So if you want to go through the exercise of creating a VM, we'll have to click on the launch instance in here. The launch instance will allow you to go through a certain set of basically web pages or forms you have to fill to see what gets created for you. So if we click on this one, you will see this particular page. Here it asks you what's the instance name, what's the availability zone for it, and what's the count. The name, you could choose whatever name for the VM, let's say test or demo or whatever, and this will be the host name for the Linux VM that you create. Windows does not follow this kind of scenario, so if you're creating Linux VM, whatever name you will have in here, this will end up being the host name. It's assigned over DHCP. And here it's saying you have 10 instances and you will be using one instance if you create that. You could choose to change the count in here. So instead of going through this form, let's say 10 times to create 10 instances, you could just put 10 in here and fill up the form, click launch, it will just open up 10 for you. The next screen that we will see is the source portion. So as you could see here, clicking on the source, you will find select a boot source for your instance. Here I'm specifying image. So images are the way you put your operating systems that you want inside your VMs. As you could see here, there's a selection of CentOS 7, Ubuntu Stock, Vert.io, Fedora, and this is a test, usually operating system that you would use CROS, basically a test that you check connections. The major ones are CentOS, Ubuntu, and Fedora. You could always add your own ones, but those are the basic ones provided when you log into the cloud. If you remember what I just mentioned about ephemeral and persistent VMs, this is basically how you choose if it's ephemeral or persistent, the portion where it says create new volume. If you choose to create new volume with the option yes, you've chosen to create a persistent VM. So this will use the storage backend that we have, storage server that we have, to host your VM. If you say no to it, then this will be an ephemeral VM that will be stored on the local compute node, and it will not take up from your persistent volume quota. So your quota will be untouched because of that. So if you select any of these and then go to the next page, which will be the flavor that we spoke about earlier. As you could see here, the flavor is basically specifying the virtual CPUs, the RAM, how many gigabytes of RAM associated with that, the total disk. I'll come back to this in a sec. The root disk and the ephemeral disk. You see here there is a flavor called P-2C-4G, which is a bit different from all the others. P, it comes back as, or it means persistent. So this is what you would use if you want to create a persistent VM. So after you choose in the previous page here, create a new volume, you would go here and choose persistent 2 cores, let's say, and 4 gig. You choose a flavor that starts with P. The reason for that is you want your root disk to be 0, such that it doesn't create any local disk on the compute node. This means that every storage that you have will live on the storage backend. So you're basically telling Openstack, don't create for me anything that lives on the compute node itself. Here, as you could see, there is multiple varieties. It depends on your quota. So there is 2 cores, 4 gig, 20 gigabytes for disk. Depends on whatever the use case and the quota you're allowed. You will be shown specific flavors out of that. So once you choose whatever flavor you want to go through, then the next page will be going through the networks. For every user that gets created an account in the Sharcnet cloud, a default network is created for them. So you don't have to worry about this part. This will be the network that you attach automatically to your VM, so you won't see any kind of asterisk in here, because automatically it will select this one. And this is where the private IPs I mentioned earlier will exist. Those are the IPs that only live within the cloud, and the floating IPs are out of those boundaries. The next one that we care about also is the key pair portion. So, actually, I'll go first through the security group. So the security groups, as I also mentioned before, there's always one that gets created for you. It's a default security group. By default, you will find that you already allocated the default one, and I'll show you in a bit how to change the default one to allow a specific traffic inbound or outbound. The next will be the key pair. The key pair here, you could either import your key pair or create a new one. Clicking on create a new pair will ask you for a certain name for the key pair, and then it will download the private key to your own machine, and it will keep the public portion in the cloud, such that it gets injected into every VM that you create. And this way, you could log in to all the instances that you create using your private key portion. So you can always add some sort of metadata to your instances. This is not the general use case though, but there is multiple ways you could add specific metadata, such as choosing where your disk, is it seen as iSCSI, or sorry, as SCSI or IDE, stuff like that. It's not a general use case, but if someone has this particular use case, there's always the ability to do that in the cloud. So in this past few forums, I just went through the portion and clicked launch instance at the end, and then I got created this one. As you see here, this is an instance name, and this is the IP associated with it. It's persistent one. It has using a key pair called student1. The availability zone is called Nova. This IP is not reachable from the internet. So you've created an instance, it has an IP, but you cannot reach it from anywhere. So what's the solution for that? The solution for that is finding the floating IP that you're allocated and then attaching it to your instances. So here, as you can see, if you click in here, you'll find an associate floating IP. Associate floating IP is basically attaching a floating IP to your instance. The floating IP is a public one, so this way you're able to reach the actual instance from the internet. So if you click on associate floating IP, you will see that there's no IP address and there's no port. This means that you haven't yet requested the floating IP to come to actually be part of your project in the cloud. So you click here on the plus sign, and you will automatically you'll be chosen to public network 199. As I mentioned, here in this demo project we have 3 available, but normally only 1 will be available for every user. And once you click it, you will be given this particular IP. So this is an example of IP 199.241.164 dot something. Here it has .90, and we will just click associate. So we're basically attaching this this IP to the VM. So we'll see that now the dashboard has changed it to something similar to that. So you'll have a private IP. This private IP, you cannot reach your instance using it. But in the same time, you have floating IP attached. This is the IP that you could use this particular command, which is ssh-i, let's say private IP.pem, whatever name you choose for your own key. And then the default username for the cloud image. So here, let's say you chose, this is Dash right now, but in normal case scenario, it's going to be either Ubuntu or CentOS or Fedora, and that's why I have it here. You choose any of these depending on the cloud image you've chosen. This particularly, any image that you upload, it doesn't. This particular username does not have to be either Ubuntu or CentOS. So if you upload your own image, it could be a different username. But for the images that we have in our cloud, if you choose Ubuntu image, it's going to be Ubuntu as a username. If you choose CentOS, it's going to be CentOS as a username. And if you choose Fedora, it's going to be Fedora as a username. And you have to specify the public IP for that and just do SSH, and it will let you through. Now going back to the point about security groups, because you still want to be able to log into your instance, you have to allow SSH to go into your instance. As I mentioned, by default, all traffic inbound is not allowed. So the command I mentioned in the previous slide, it won't necessarily work. So what would happen if you go now to the Access and Security tab and look for security groups? You'll find that there is a manage rules in here for your default security group. As you see in here, every one of these is basically a rule in the firewall for the security group. It says here IPv6 coming from any, just disallowed. So because it doesn't say any remove prefix that allows in. Egress IPv4, so anything that's going IPv4 and going outbound, going to any IP, is just allowed through. In this case, I've already added previously the ingress traffic for SSH. So you have to specifically say, I want SSH to be allowed in, and I've allowed it from any public IP. This is basically opening your VM to the entire internet. If someone wants to log in from anywhere in the world, they could do that. They still have to provide the right key to log in, but basically from an IP standpoint, the VM is now open for anywhere in the world to log into it. So normally you would choose your own IP for that, just from a security perspective, to make sure that you are the only IP allowed to reach the instance. But if you want to add a rule, we'll just click add rule previously in here. So we say add rule. And we'll see that there's a custom TCP rule. There's lots of rules in here that you could choose out from. Predefined rules that say HTTP. You click on it and it will tell you which port to fill in here. So it's a predefined set of rules basically. Here you can say, okay, I want this ingress traffic to come through this port, and you specify the port in here. And here you specify where is the source IP that's coming from allowed. So if you specify 0.0.0.0, it means that everyone is allowed in. If you want specific IP to be allowed in, you could always do that in security groups. And then you could edit your instance if you have multiple security groups. You could always edit your instance such that you move the, let's say you have multiple security groups, you can keep adding ones or removing ones. So if you click minus in here and then you have extra ones in here, you could always do plus and it will add additional firewalls or different firewalls to it. So again, this is basically how a normal VM in the cloud would look like. Basically, an instance name in here, which will be the host name, a private IP, a floating public IP. This is the sizing for it, which is called the flavor, the key pair associated with it, and being persistent as a VM is more advantageous from the fact that you have multiple copies of your data. But as I mentioned earlier, you always limited by a certain quota. The default quota is 50 gigabytes of persistent storage, so it's a very limited number of VMs that could make use of that. Some common notes about the cloud. The default behavior for this cloud is that VMs and volumes are not being backed up. So the best way is always to keep a backup of your data. If you have a use case that your VMs need to be backed up, please reach out to us and we will see what we can do to help out with the backups. Obviously, the usage of the VMs and the network is like any other computing and network resource. It's bound by university acceptable usage policy. The last thing is we've architected this cloud to provide high availability when it comes to Openstack core services such as network, compute, and volume service. But this cloud is not designed to host mission critical applications. So if you have a use case that you think is mission critical, please reach out to us and we can discuss what's the best way to solution it. Thank you very much for your time today, and we're now open to questions.